Thanks for joining us today to talk about test-driven development with Chef Workstation. I'm super excited to be here today. My name is Heather Payton, and I'm a product marketing lead here at Chef, specifically working with Chef EAS, Chef Infrastructure Management, and Chef App Delivery. Along with me, I have John Tonello. John?
Hi, Heather. Hi, everybody.
Who is a technical product marketing manager and has just brought a wealth of experience in this space to Chef, and we're super happy to have him here today. So with that, we're just going to go ahead and jump right into the agenda. We're going to start with an intro to test-driven development, specifically talking about how test-driven development applies to infrastructure automation, kind of Chef's take on test-driven development, and then moving into how we do test-driven development using Chef Workstation. John's going to do an overview of Workstation and a really cool demo. And at the end, we'll take your questions. I encourage you, if you have questions, go ahead and feel free to enter those throughout the event, and we'll take them at the end. And also, what would be a Chef event without cool swag? So we'll be announcing the winners of some swag during the Q&A at the end of the event. Okay, so with that, let's just go ahead and jump right into it. So test-driven development, testing is not a lot of people's favorite subject. Let's just be honest, like testing is hard. It's always kind of, I debate, is it hard or is it boring or is it both, right? But there are hard elements. If you don't have clearly defined requirements, tests are hard to create. If you have components that really weren't built for testing, you don't even know how you can test them, that's an issue. Accessibility to credentials and secrets and getting to test environments, and test data, classic challenge. Testing can be slow, writing tests is slow sometimes if you're doing it manually, especially if you're clicking through an 80-page Word document on a screen or GUI, really slow and painful. Troubleshooting tests can be slow. Waiting on dev test environments, another big challenge in the testing space. And testing can be expensive, especially if you're doing things manually, if you're having to use business stakeholders to run tests, if you have large test beds that take days to run, and you need really kind of solid pre-prod environments, all that can add up. So I never heard this word YOLO used in business till I started, working at Chef and learning about DevOps testing. So why not just YOLO it, right? Who has time for all this testing? But like the skydiving picture here, like sure, the risks seem low of dying in a skydiving accident, right? But what happens after you jump out of the plane and you turn to the guy next to you and they say, these parachutes haven't been tested for a year. The person that was in charge of that was new to the job and didn't have requirements, so they just skipped it. Like that just made the acceptable level of risk really jump to a new level that you're probably not comfortable with anymore. So in the end, we know testing is extremely important. And having testing challenges many times signifies bigger business challenges, right? If we look at Accelerate, which is a book by some of the DevOps titans, Nicole Forsgren used to work at Chef, Jez Humble, also an ex-Cheffer, and Jean Kim, they clearly draw some quantitative data and examples on how deployment plane and the inability to get changes into production quickly without fear and anxiety also impacts business outcomes, right? There's a high correlation between business pain and business outcomes. So as we know, if we have dev teams working in one environment without visibility into all of the requirements on the other side of the fence, this leads to unexpected failures and ongoing challenges, config drift being a big one there. So being able to test the same way we do in dev, the same way we do in pre-prod, to the same way we run in production is really important to enable businesses to achieve their business outcomes. And this is an oldie but a goodie, right? Like, yeah, testing can be expensive, but so are production failures, right? And there's tons of non-app related failures that can cause downtime and or performance issues. It's not just challenges with app code. So enter this continuous delivery series that we're launching with this event. And really our goal here is to help chef clients and other people who are really trying to scale DevOps and continuous delivery within their organization, kind of conquer some of the most common challenges we see within our clients every day. So the ability to drive test-driven development at scale, that's what today's call about. Next month, we're going to be here with Trevor Hess talking about how we can enable on-demand dev test environments, another huge challenge in testing. And in September, super excited to be here along with Aquilas. If you haven't heard of Aquilas, they're a SaaS-based secrets management provider, and they've really got some cool stuff. We've got a new integration coming with Infra for secrets management, and we'll be kind of hitting that topic in September. So back to test-driven development, why we're here today. So if you look at this definition of test-driven development, really kind of what stands out here is software, right? But software is more than apps. It's also infrastructure as code is a code base, aka software. Policy as code is code, aka software. And automation is code, even more software. So, you know, everything, once we move to this as code world, you know, the principles of software testing become more and more applicable to infrastructure automation and policy automation. And we know app changes are not the only things that can disrupt business, right? There's many factors that can influence the stability of a given app. There's agents, there's OS patches, there's database schema changes. There's lots of things that can cause a production failure or inhibit performance of a system. So let's maybe redefine test-driven development. And if we look at test-driven development as a process for managing IT changes that rely on requirements and policies, it really becomes directly applicable to the lives of IT operators, of infrastructure managers, of everybody who's really implementing any type of change that's going to touch a production system. And there's tons of benefits of test-driven development, right, for apps, infrastructure, and compliance teams. So one, risk reduction, catch more defects before they reach production. Obviously, the more we test, the more defects we catch. Minimize security breaches, all pretty much common sense stuff here. Improve quality and ship faster. This is a little bit different of an angle. Here, we're really talking about the quality of code we build, the quality of automation code that we build, the ability to automate testing for infrastructure and compliance policy changes, and really scale continuous delivery to that next level, removing those manual gates, removing those things that have to be tested manually, and hopefully reducing operational overhead. The easier code is to understand, the easier it is to maintain, the easier it is to reuse, using tools like Chef Cookstyle that we'll talk about to minimize debugging time and minimizing rework. So in the new world, we can almost think about automated tests as the defined business requirements and policies, right? We take a written policy, a written requirement, and we convert it to an automated test. And this is something everybody does, right? Requirements and policies are set by the business. The work goes into IT and gets implemented by DevOps teams. How automated that is determines how long it could take. It could take days, it could take hours, it could take months. I think John was talking to me about an example of a company one of his family members works at. That big change could take a year because they can't test. So in the end, though, the business is going to want some validation that the requirements were implemented back to them. So really the unknown factor is how good a company is at this and how much this process is automated. So back to TDD Basic Concepts, right? So if you read about TDD, you're going to see these common phases, right? So the process of TDD is, one, the test is going to be defined first. So you write the test first. And this is really, really critical, right? Because if by writing the test first, we're confirming the business requirements, right? We're validating that, yes, this is what the business wants. We're creating a piece of automation then that can be used to, validate the business policy. There's no more manual gates involved. And it ensures the controllers are all in one place in an audible code base, right? Green, then, the minimum amount of code is created to pass the test. We ensure the test is passed. And then once the code passes the test, refactoring. And refactoring is just such a huge opportunity in our space specifically. Being able to remove duplicates. We hear stories all the time of, clients with multiple cookbooks for the same thing, tons of duplications. The bigger that code base grows, the less clean it is, the more expensive and harder it is to maintain. And it's also a lot harder to upgrade to new versions of tools, right? Another interesting thing here is if you read about Agile and Waterfall, one of the kind of big points of controversy of moving from Waterfall to Agile is, a lot of purists believe, great software and great architectures are designed to be great. They're not tested to be great. And this kind of really kind of closes that gap around kind of shorter design cycles and instead, constant improvement by test. So by implementing test-driven development, we're continuously evaluating the business requirements, developing those tests and driving good design forward. So testing types. So developer code and testing, this is pretty straightforward. These are tests to really analyze individual code, make sure syntax is nice, make sure style is nice. Chef Cook Style is a static code analyzer and a linter. It helps bring kind of the how to do chef best analysis to the code, and John's going to cover that a lot in his demo. The next set of tests is the testing pyramid. Pick your favorite testing pyramid. I picked this one, but this is really the functional testing of where we're ensuring that what's getting released to production meets the needs of the business, starting with unit and component test, basic single unit, single component test, into integration, where we get into putting multiple pieces together, multiple systems together, multiple cookbooks together, business process testing, long running end-to-end test, usually used by the QA team, and then GUI and exploratory testing, which is usually hands-on keyboard, expensive, done by the subject matter experts in the business. And then we have this next set of testing. And when we started working on this content, one of our big challenges was, how do we frame the type of testing we're doing as it relates to a cookbook, right? And if you look at DevOps today, modern day DevOps is really all about automation and tool change, right? And if you've been using DevOps tools, you've got Chef, you've got Jenkins, you've got Hashi, you've got Ansible, got all these other code-based DevOps tools. There's a huge code base, right, that has been built in support of all those tools, probably thousands and thousands of scripts, and they all need to be tested and maintained. So we're actually kind of building this group of testing of DevOps testing now. I don't know if it's the right name, and if you have a better name, let us know, because we've had a great debate about this for the past week. So in addition, there's SRE testing, really talking about how do you get to availability and load testing. This can get extremely complicated if you have on-prem, multi-cloud, multi-environment, edge environments. How do you handle load across all of those different environments, across all of those different geos? And then on the top, security testing, referencing here, really kind of, again, penetration testing, testing that's usually pinged into the UI, really kind of stress testing those business processes and the underlying architecture. So where we're going to be focused today, and we're going to be talking about where we feel Chef plays most directly, is linters, integration, and DevOps testing. And we've kind of taken a shot at defining on the types of tests we're running in each of those phases. Granted, there's gray zone between these always, but linting, we're looking at standards, best practices, syntax and style. Devops testing, logic checking, checking specific configurations, architectural conformance, validate interactions, versioning, interaction between two components, multiple cookbooks for integration, functional and advanced. And one thing I didn't mention back here that I want to just mention quickly is we also want to be careful, right, when we're testing Chef. When we look at COT software, we don't want to be testing stuff that we bought the software to do, right? So when we buy salesforce.com and we hit that, opportunity report button, we don't need to test that Salesforce generates that opportunity report, right? Like that's what we're paying Salesforce for. Similarly with tools like Chef and Jenkins, we don't want to be creating tests for things that the product's supposed to do. So that's why we really feel like it's more of this area of DevOps testing versus unit and component testing. So last couple slides before I turn things over to John. So we really see test-driven development as the way forward with implementing policy as code and secure infrastructure at scale. In today's world, security is really the responsibility of everyone, right? And really how we bridge that gap between compliance, security, and DevOps is through compliance and policy as code. And that's really what we're getting with policy-based compliance, right? It's the language that's the codification of security and compliance, where your stakeholders, are able to directly communicate and work with each other. It's all audible, verifiable, and we get that validation back to the business. So now we've kind of talked about the setup, the concept, and Chef's perspective. I'm going to be turning, whoops, sorry, forgot, have one example. Great blog here by ScaleSec that really kind of reaffirms policy as code and TDD, and that this is really a concept that's getting legs out in the industry. This is specific to running compliance on Google Cloud using Chef Inspect. Really a great blog, highly recommend taking a look at it. So with that then, I'm going to turn things over to John now, who's going to kind of dive into Chef's approach to TDD and do a great demo.
Thanks, Heather. I think we're just going to switch ownership on the slides. Okay. Always joy in sharing. Good morning, good afternoon, everybody. Heather went through quite a bit of stuff, and we're going to now, over the next few minutes, talk a little bit about the reality of test-driven development using Chef tools, and particularly using Chef Workstation, which is really the heart and soul of doing all the kind of work that you're going to be doing as a developer to be develop your scripts, develop your tests, your code, interacting with the different servers, doing pretty much everything. And it's important because DevSecOps teams need to have a consistent and powerful tool set, and a testing environment, especially nowadays when there are so many tools, everybody wants to bring their own. And with Chef Workstation, which is a free tool, and you can download it from the chef.io website. It's available for Linux, Mac, and Windows. It can install on nearly any laptop or workstation, even in a virtual machine. There's even a Docker container out there for running it. But once installed, it provides the latest versions of the Chef client, Inspect, the Chef CLI, Habitat, Kitchen, Cook Style, and really gives you the power to do everything we're going to be talking about here today. So as we get started into this demo, you'll see that I'm using, in addition to a CLI on a desktop running workstation, I also am running VS Code, which is also freely available. And it's one of the IDEs that Chef makes plugins for that really help advance your coding, and has great syntax highlighting. Really will insert whole chef package resource stanzas for you, and give you really great visual cues. Plus, it allows you to see all the content within your folder structure, your cookbooks and profiles, and everything that you're working with. I think there's a little example GIF here that shows, and you'll see some of this when I'm interacting live, but you can see how the IDE can really sort of begin your testing journey, because as you're working, and if you're not a chef pro, or if you're working in new areas, this can really ensure success right out of the gate. And of course, the code itself, as you'll see here and a little bit later, the whole goal of the chef language is to have it be human readable. So anybody across your teams can take a look at a cookbook or a test that you've written or somebody else has written and understand what's happening there. There are 489 as of today built-in compliance resources, and 158 different infrastructure chef infra resource that can be used. And it's highly extensible, and you're not limited to just those. You can create your own as you go forward, and whatever suits your team. So the Chef Workstation experience is largely a CLI experience. And once you install Workstation, which is a package that you install, and you can do a couple things to point to the embedded Ruby and other packages that come with it. Do a chef-v, shows you the version, and it's of all of the packages that are installed. And as Heather talked about, cook style is included in there, and we'll see a little example of that as we go on. Cook style itself, because chef language is very close to Ruby, it's specialized in many ways to do kind of things that we're looking for, our customers are looking for chef to do. But cook style incorporates rubocops, which are basically syntax helpers that can detect and correct hundreds of syntax, style, and code errors and autocorrect them, which is nice. If you're somebody that likes to use a code editor and you realize that there's a problem in everything, and you open a million files and then do a search and replace across all those files and then save them all that goes away with Cook Style, which can fix things very nicely. Test Kitchen itself, and this is a bit of an eye chart, but Test Kitchen is a component of Workstation that allows you to create basically target instances that replicate the real platforms that you're going to do your work on. And you can use a variety of different drivers to do this, meaning you can spin up these instances in Docker using Docken. You can use Vagrant and packages like VirtualBox or Parallels, or you can use public clouds like AWS, Azure, DigitalOcean, and others. And what it does is create those environments based on the real thing, the Linux environments and that you're planning to deploy into production. And you get real-time verification of these systems and your code running on those systems. Then, of course, you're going to converge your code, which means applying your chef recipes and cookbooks to those nodes, testing it, and then being able to actually log into those systems. They behave just like a live system. The nice advantage of Test Kitchen is, in addition to all that, is that it's very fast, particularly if you're using Docken, which I'll be demonstrating here in a few minutes. But this is an example, too, of the inspect test, where in test-driven development, you're really looking for what is the outcome. So when Heather was talking about, you take some written policy that the company has come up with, and you're turning that into a test and then later into code, it might look something like this. And these can be specific to your application. They could be more broadly applicable to the platform that you're on. You may have rules that say, port 22 has to be open for SSH, but there's no password logins and no root logins and things like that, things that you can test. And the outcome in Workstation from the CLI is very obvious. And the results of the script, the test script on the left, when you run it to verify it, looks like what you see on the right in the CLI. And if you go even further and integrate into Automate in the Chef Infra server, you can see this stuff in real time over hundreds or thousands of nodes. So right now, what I'm going to do is I'm going to switch over. I'm going to stop sharing this. Just bear with me a second. Okay, you should be able to see that. One of the keys that that I'll be showing off here as part of Test Kitchen is this idea of a kitchen file. And a couple things to point out. This is a generic kitchen file generated when I created a cookbook. And what you'll see is the basics, a driver, and this can be, in this case, it's going to be Dockin. The provisioners is how it's going to be deployed onto whatever nodes I'm looking to use. The transport, which will allow me to shell into these nodes, and a verifier, which of course we're using inspect. And one of the great things about Test Kitchen is it enables you to test multiple platforms all at once. And in this particular kitchen file, I'll be testing on Ubuntu 20.04, and I'll be testing on CentOS 7, but I could list a dozen of different systems, different permutations. I could do Ubuntu 18.04, I could do Debian 10, all at the same time. And regardless of how my actual test changed, this will be essentially encapsulated and will be spun up as I'm doing my work. So let me, what's the next? One of the key things, since I'm running Visual Studio here, VS Code, you can see right off the bat the highlighting. But if I go in here and type something that, because I'm in chef mode, I can say, you know, a resource, whatever it happens to be, like it understood the platforms that I was looking to do. I can autocomplete through a lot of that, and we'll see that in a second. Let's see. One of the, I just wanted to show before we move on to running this cookbook that I'm about to create, is this is a kitchen file that will work with AWS, whereas the Dockin one is going to create some containers on my local machine. This is actually going to spin up nodes in the cloud and do it in my AWS account. So same thing down here with, it's going to create an Ubuntu and a CentOS 7 box to do the testing. And instead of doing it locally, I can spin up 10 different types in the cloud. Very flexible. Vagrant is also workable for those who want to do testing with full-sized systems. So what I'm going to do here is I'm going to first generate a cookbook and then take a look at the results of that. And ordinarily, when you create a cookbook, let's get into my documents just to get this. You would say chef generate cookbook in the name of the cookbook, like this. But what I'm going to do is add this little K to it and put in Dockin, and this is going to create that kitchen.docking file automatically for me. So if I look at the source of that kitchen file right now, you can see in this terminal view, looks exactly like the one that I had already provisioned. In fact, I don't have to do anything to this. It even included the name of my default cookbook into this run list inside. So that's what that looks like. And what happens when I do that as well, it created a whole bunch of other different files and folders. Of course, if you're familiar with Chef, the recipe is the king here. And this is what will actually do the work of changing a system. And what I'm going to do in this example, I'm going to use a Chef to deploy and test Cowsay. And I want it to be so that each one of my systems, when I log in, I see a little balloon with the IP address of the node under the little Cowsay graphic that I'll make into the tux character. If you've ever used Cowsay, it's been around for a long time. It can be handy to create fun kinds of things with just ASCII code. So within this code itself, you can see, because one of my requirements is to run my application on multiple platforms. So I'm going to run this on CentOS and on Ubuntu. And in the Chef code, I've added a platform family of RHEL, which CentOS is a part of. And I'm saying, install this EPEL release repository as part of that installation. But if you're using, if the target is a Debian family, and obviously Ubuntu is, just run this app update. I don't really have to run this, but I want to show that there's a full if-else testing logic that's in place here. If I had even more, I could use a case statement in here and then later test each one of those. I install the package Cowsay, which is very simple. Next, I will go through and write a line of text to the etc profile for these nodes that will basically take the host name and pump it into Cowsay and output it with this little tux character. And one of the things I'm doing here too is saying, don't do this if this line already exists in the profile file, because I don't want Chef to create new lines every time I converge my code. And finally, on Ubuntu systems, I want to add a symbolic link to a more standard location for the Cowsay binary. Ubuntu puts it in this user games Cowsay, and I want to make it more consistent so I can trigger it and the systems can fire it. Now, in order to do the test of this is very straightforward, and it's showing I'm describing a package Cowsay and it should be installed. And you'll notice that I haven't had to put in here, if it is RHEL or if it is Ubuntu, Debian. I just want to know if it's installed. So the test here is really, as simple as this is a test of the logic that I've put into my recipe. And next, I'm also detecting that file, detect if the Cowsay command is indeed in the profile, so that it fires. Now, I could add a whole bunch of other tests here as well, even those that aren't necessarily specific to my application. For example, I could be testing if port 22 is open. I could be testing that port 80 is closed. I can test that if I don't want sudo on here, other sort of base infrastructure pieces for my nodes that are important to whatever my policy is. And then I can make that as part of it as well. So with these two things complete, I'm going to open a terminal here, still in VS Code, and move into my Cowsay directory. And I'm going to first do a kitchen list, which tells me, sorry, I have to reset my kitchen YAML file. This is because I have different kitchen files in here. Telling to use the Dockin one. So you can see I have the default Ubuntu, I have the CentOS, they're going to be using Dockin, and they're not yet created. So all I have to do to create the actual machines, and this is doing it on this workstation using Docker and spinning this up in real time. I've previously run Ubuntu and CentOS systems on this machine, so it's already, Docker has already pulled down the images, but everything else is basically happening in real time. If I was doing this with the AWS kitchen file, it would be going out to the AWS servers using my account and my credentials, my IAM credentials to do this, and then would spin up two devices in the cloud. Of course, this is taking longer than I would expect.
Hey, John, why that's happening, there's a question. Why would we use Kitchen Dockin versus Kitchen Docker?
Good question. Kitchen Docker is basically it's not deprecated, but it's the old way of doing containerized Docker-like testing with Chef. Dockin has just a larger number of features. It's far easier to use. There's better integration naturally into the tool set. And you can get started much faster with Dockin. The name, and it does come from the 80s band, if anybody's familiar with that. But it is really the modern way to use containers. Okay, so my two containers, in this case, my target nodes are created. So I'm going to do another kitchen list, and you'll see now that they'll be created. But I'm also going to just do a Docker PS that's going to show that, hey, Docker's running and these containers are running. And these containers aren't just light versions. Dockin and the images that Chef provides for this have things like systemd and other features built back into them so that they behave more like VMs than limited containers. So now I'm just going to do a kitchen converge, and this is the step, if I can spell it right, that takes my code from my recipe and applies it to those nodes. Now, a couple things else are happening here. It's applying a Chef client. It's creating a credential connection for me automatically so I can shell into these nodes. And it's giving me obviously the real-time feedback of the actions. And you'll notice as it goes through, if you can see some of this output, it's running apt actions during the Ubuntu installation. And on CentOS, it's running Yum tools and the package manager. Each one of these things is determined not by you, but by Chef itself. And again, here, I'm not checking really to see when we get to this point that these things that Chef did the work, but I'm really going to be testing that my logic is correct and that it's doing the right things on the right platforms to meet my test goal, if you will. So this is a process. If you're doing this with AWS, it takes a little bit longer. It takes, depending on where you are and which region, it can take a little time for instances to become live, but it is pretty much as fast as what you're seeing now with Dockin. So I'm just going to run a kitchen list again, just so you can see this intermediary step that, yep, they're converged. And now I can run kitchen verify. Now this is taking, and might be good if I could spell. It's taking this script and applying it against my two nodes. And this is using an inspect test. I can see, hey, Kause is installed on Ubuntu, and it's installed, and it's written the output to my profile file. Now, I can see again, if I run kitchen list, that, hey, they've been verified, gone through all those steps. But we always say with testing, it's great to do these kinds of tests, but the real test is to actually run the thing that you had installed and make sure it's configured the way that you wanted it to be. So with Test Kitchen, I can log in to either one of these nodes, and this applies whether I'm doing it locally in Docker or in AWS. It's the same command. I know that the machine name is CentOS-7, like that. It's going to do a secure handshake. I'm going to log in, and hey, there's Tux with the IP address in this little balloon. Now that's the CentOS machine, and that address is 172.18.0.3. If I log out of there and log into the Ubuntu node, huh, 172.18.0.2. So in this case, not only did my tests work, my code worked, my converge onto these systems worked, everything is in good shape, but the actual outcome worked, which is very important. Now, one last thing before I move on to the next thing. You can do a kitchen destroy, which will now get rid of those containers, absolutely purge them from your system. Essentially does a Docker prune in this case, but if I was on AWS, it would shut down those instances automatically. Now, if all these steps are, I think there are 5 steps in there between create, converge, and everything else, I can run just a kitchen test, and it will take that same kitchen.yaml file, create my target nodes, converge the code, verify the results, and destroy the nodes when it's done, all in one step. Now you might say, well, how do I know if it worked? Well, at the end of it, it's going to also show me the green output of the result of my test. I'm just going to switch back here. Bear with me a second. Sorry. Too many things open. Okay. Now, these are all the steps that we just ran through, and I just wanted to show an example of.
Hey, John, you're on the speaker note view. If you want to go into the full screen. Sorry.
Let me. I think it's because I tried sharing before I did that.
Hey, I am no one to judge.
And sharing again. Let's see. Okay, how's that?
Perfect.
Better? This is what I was talking about, where, I created Cowsay and I had it do its fancy thing when I log into my systems. But even before I deploy an application like that, I could go through and apply sort of a benchmark. And for users of Chef Automate, who've seen, there are over 450 steps that you can, available benchmarks that you can use, and they're very sophisticated. Everything from specific kinds of risks for known viruses or attack vectors, things like that. But for example, without creating any cookbook or recipe, I could have run a script like this. Oops, I should not click on that. To say, describe port 22, and is it listening or not? Is my SSHD config, does it not have this permit root login? Yes, which would potentially be a hazard. But this is just one example of the kinds of things that you could do en masse within your test suite to really bring your tests into a level that matches what your true policies are. So, it's often a multi-step process, of course, but iterating through it is something that's very easily and quickly done with Test Kitchen, which is amazingly powerful. And hopefully, in this demo, it showed you how to think about, the many ways test-driven development can improve your outcomes. And in this very small Test Kitchen example with Inspec, I hope you got a sense of the speed of that you could go through your testing and your development and really iterate and get the outcomes that you want. With that,
John, that was great. I have just one question for you. In the Test Kitchen example you just went through, what would be your refactoring steps then you would perceive after?
Good question. I had the test there of testing for RHEL and testing for Debian platform families. It could very well be that later on I need to test on 6 different platforms, and creating an if-else statement for all of that would be a little cumbersome and complicated. So in a case like that, I would probably refactor it into using a case statement. And I also had a bash command in there, which was fairly straightforward, but I might also find other Chef resources to do that sort of thing. That's a little cleaner, perhaps creating a template or a file that I could share without having to sort of manually do certain steps. But those are just a couple.
Awesome. Thank you. Just going to move on. I'll just remind everyone we're going to move to the questions in a second. I can't say second. So if you have questions, feel free to go ahead and type them into the Q&A panel. So just a quick summary here. Also, I didn't mention if anyone would like a copy of the presentation, just feel free to ping the chat. And I can go ahead and email you a copy or a link to the actual slides if you'd like some of the slides. We also will send out the recording. So just a quick summary here. Chef Workstation is really our platform for enabling test-driven development. With Chef Workstation, you get Chef Cook Style to help lint and do static code analysis. Chef Inspec. I know there was a question about, is Chef Inspec included in Chef Workstation? So there's a big yes here, along with all of this certified profiles and content. You can go deep into system config testing and into app config testing with support for Docker. So tons there. We also have the premium content now for remediation if you haven't checked that out. And then Test Kitchen, which, really helps eliminate all of those like testing is hard and slow challenges. You get dev test environments, the integration with Docker, the ability to run the same test across multiple devices. We also have Foxeye, which is a mocked database, including a bunch of OS settings and things like that. So really an accelerator for doing testing in that DevOps testing space for sure, and even moving into some of the integration testing. Next slide is some quick resources here. If you haven't seen it or been involved, we have a Chef Infra Best Practice series also going. You can see we've got 6 recorded events there, including running Chef Infra Cookbooks Fast with Docker, which is actually a Dockin webinar. And then we also have a webinar on Cook Style. And then at the end of the month, we're going to have a little bit of a deeper dive, more of an overview of Chef Workstation with Dan Reb from our DevRel team and a long-standing sous chef with Chef. So last thing is ChefCon. If you haven't registered, please do. It's going to be awesome. It's going to be tons of sessions. We've gone through the abstracts. we have so many great submissions and great content coming, tons of valuable information in addition to swag, of course. And we're going to have some type of band party at the end of the event. So should be a lot of fun. Hope to see you all there. So with that, then we'll move into the Q&A.
I see. I don't know if you're starting at the bottom or if you're going from the top.
Question, John, whatever one.
It says, is Cookstyle available on PyCharm? That's a good question. I'm not entirely sure. If you do check the latest release notes, it does highlight some of the Rubicops and the things that are being tested that way. It tends to be, since it is Ruby, but it's beyond Ruby. Good question there, though. Sorry, I couldn't be more specific. I don't see mention of visual testing. Are you considering visual testing as part of this TDD from Chef? Not really sure what you're referencing as visual testing, other than sort of the actual outcome. Perhaps you could be more specific, not just seeing the code go by from a terminal and not just seeing the result that, hey, Cowsay is working, or my Jenkins server is up, or a Tomcat is running, actually testing the live piece. There is not something within this that will show you, like in the CLI version, that's going to show you the state of your systems. But when you move into the level of automate and the compliance phase, you can get a visual of all your systems, all the various cookbooks and tests and the inspect profiles that are running against them, and gives you visual cues to that. It says, do you have to have a working Chef infra server or Chef Automate environment available to use Chef Workstation, or can it be locally? Actually, everything I did today can be done just with Chef Workstation. There really was no activity happening here that was using infra or automate. When you deploy a cookbook and you have the default kitchen.yaml file that uses Vagrant, you'll see it uses Chef Zero, which is basically a mini Chef infra server that is doing the work behind the scenes, but it's all doing it locally. Now, when you graduate to the next level and you want to be doing all this stuff on a variety of other systems, VMs, hardware, stuff in the cloud, that's where Chef Infra and Automate really come in handy, because now you're shipping your code to a common code base and being able to have it pulled by systems anywhere. But for everything that I did here today, you just need Chef Workstation installed.
Hey, John, I'm going to jump in a second. We have a couple of questions in chat, but I also want to announce the winners of the swag today as we get near the end of the event. So please excuse me if I don't get your name right. Our winners are Andy Herm, Eric Amshe, and Stephen Corbzero. Sorry, I'm killing your name, Stephen Corbzero. So congrats on our winners. You'll receive an email with a link to pick your swag. We also had a question in the chat about we have Chef Server 12.1 in Ruby version 2.75. Which workstation will work well? The answer is, at the current version of Workstation, you can use, you just will not have all of the policy file capabilities. So there'll be some limitations with policy files, but you can use the current version of Workstation. With that, then, John, we can go back to the Q&A. I don't know if you have another question picked out you want to answer.
There was a question about running Test Kitchen on multiple cloud providers like AWS, Azure, GCP. Can you do it all at once, or do you need different doc and different kitchen files? And generally, yes, you do need to have them, because the credentialing and the platform they're using is different. They all have different drivers. And I was just thinking about that. During my demo, I did that export kitchen_YAML equals the name of the kitchen file, which is a way that you could run tests across everything by just adding that variable when you're running kitchen list or any of the kitchen commands. You could be firing off all of those at the same time, or nearly same time, as fast as you could do them. Let's see, there's a question in here. Is there the slides for the build test? Yes, I think these slides are going to be available. I'm also, and this is because you're here, you get to hear it first. There'll be a chef guide that I have that goes through a lot of this in a lot more detail that you'll be able to download and try. And is there community created commons tests available? You know, there are a number of tests that are available out there. Frequently, sort of the simple tests that I have, which aren't full-blown inspect profiles, are companions to a lot of the cookbooks that are available in the supermarket and elsewhere. But there are quite a few resources that you don't have to start from scratch with most things. If you've deployed it, if you're looking to deploy it, chances are it's been deployed before and someone has at least written some code to give you a head start, which is a great thing about being an open source company. There's a lot of people around the world doing your work or helping you get started with your work.
Great. With that, I don't see any more questions and we're about at the event time. So wait, here comes one. Sorry, we'll take this last question then.
Yeah,
the test kitchen resource. Yeah, go ahead.
Similar in Windows and Linux. Yes, the test kitchen and all the workstation apps work exactly the same way on Linux, Windows, and Mac. Obviously, running Docker is a little different on Windows than it is on Linux, which is different from Mac. But as long as those environments are set up, for example, for docking, you would do the same kitchen list, you would do the same kitchen create, and do all those things. Same thing with if you're using the AWS CLI, which is required to do some credentialing. Same, you would install AWS CLI on Windows just as you would on Linux or Mac, and it would establish those credentials. Workstation knows how to talk to those credentials and make everything happen. But all the commands are the same in Workstation across all platforms. And since it embeds its own Ruby, there's a standard as well. So you don't have to pre-install Ruby or other packages to make it work on any of those platforms.
And I actually did see one more question in the chat. I'm not sure if we'll be able to answer this, but I'm still in Chef DK 4.13. Can I safely upgrade to Chef Workstation, have the new dock-in functionalities, but not use the way I used Test Kitchen before?
Yeah, you know, there's a way to use a number of the tools in Workstation while maintaining older versions of Chef in parallel. You no longer have to use it specifically for each one. One of the things I've suggested to people who want to dip their toe in the Workstation, the Chef Workstation pool, is to spin up a VM with it inside. And there's even a Docker there's a Docker image available as well for it that you can try it and run it side by side. But our developers had that very thought in mind. They didn't want people to lose any of the capabilities that they had. But Workstation, all the green output and all those inspect tests aren't doable at all with Chef DK, which was deprecated at the end of last year. So Workstation picks up where Chef DK left off, but giving you a number of other features without really impacting a lot of the things that you used to do. And the latest Chef Workstation is now using, it now includes Test Kitchen 3.0, which is the very latest. So you're always benefiting from that. And of course, as things change over time, we're always looking at non-breaking changes over time. That's not always possible as software moves forward, but there's quite a bit more available to you in Workstation.
Okay, one quick question then, and this will be it. It is it's an upgrade or uninstall from Chef DK to Chef Workstation. John?
That's a good question. Every time I run, because what Workstation is really doing is installing. Yes, Workstation is one of the packages it installs, but it's installing Chef Client, Chef CLI, Kitchen Cook Style, all those things. It will overwrite those versions unless you specify a different location or do something really unique in the installer, because Workstation is installing multiple things. So if you have an older version of Cook Style on your system, installing Workstation will likely overwrite that and replace it with a new one.
Cool. Awesome. With that, I know we're past time. Thank you everyone for joining us. Feel free to reach out on the Slack community with additional questions. If you asked for a copy of the slides, we will get those to you. And hope you'll check out the rest of the series, and maybe we'll see you on the Dev Test Environment event next month. With that, Reza, we can go ahead and close the call.